Kingon, and I work at a cybersecurity company called MWR Info Security. I am a software developer full-time there. However, on the side, I quite enjoy pestering the consultants for details and that sort of thing, and I go to the exploit nights and stuff that they run, which is pretty cool, and it's sort of how I found out about one of the topics that I'm going to be talking about here tonight. And you can find me on Twitter over there. Okay, cool. So what's the deal with hacking, or why did I really choose it? I suppose there's a few different reasons for it. First thing, I guess, is it's informative. I think to some extent we can get an idea of what Hollywood likes to tell us. But it's good to, I think, know what can happen if your systems are breached. This is probably one of the key aspects of it. Remember to upgrade or update your applications, especially when serious security flaws are discovered and patches are released. Yeah, you don't want to be left standing there, especially if you've got a higher profile website for people to gain access to. Some people joke, some people don't joke, but maybe you should be aware that maybe the NSA really is watching you. And then the other really cool part of it is it's fun. I don't know, it's pretty cool to be able to gain access to different systems and to mess around with that and see what you can really do and how much you can actually get access to. And then the other question to go along with that for the name of the talk is, why Ruby? And the simple answer for that is ultimately just metasploit, the metasploit framework actually. And what's really, really cool about the metasploit framework is it is a tool that's written in Ruby. And it's a very, very active project actually, a lot of contributions that go on with it all the time. And yeah, it's actually really, really powerful to get stuff going on that. So just a few things about what Metasploit is. Metasploit is, it's a platform really that's designed to allow you for developing, testing, and executing exploits. It's a penetration testing tool. And yeah, what's also is nice about it is the whole modular approach that allows you to match exploits with payloads. And I'll get into details with the exploits and payloads in a bit. But basically, you often need various you need to choose an exploit, you need to choose a payload, and Metasploit allows us to actually select the correct one based on the system that we're targeting. It runs on both Unix and Windows, and it can then obviously target sort of any system. And yeah, it comes with many modules, which are where your exploit nops and payloads, encoders, etc. There's a few other folders and stuff that fall under that. And that's often the area where things are getting pushed into being updated, especially the exploits section. Preferred OS, most people have actually heard of Kali Linux. Kali comes with a huge range of tools and that sort of thing that allow you to do penetration testing. It comes with all sorts of different sniffers and password cracking tools and all that sort of stuff. And Metasploit comes pre-installed in it as well. One of the newer ones, I think, sort of is Backdoor, also running Unix. And it's actually, Metasploit's actually starting to really support this one quite a lot more now. Going forward, you might start seeing people who do use things like Metasploit and other penetration testings choosing Backdoor over Kali. A few other tools that are available that do very similar type of things. Most of these are actually paid tools. What's nice about the Metasploit framework, it's the community edition, is that it's free. Anyone can try it out, test with it, and do different things like that. Another fork of that is Metasploit Pro, which a company has taken, and you can actually purchase a subscription for that. It gives you a whole pile of things like a GUI interface to work with and a whole pile of other options set up in that. Cobalt Strike is really, really cool. Quite expensive, but really cool. It can set up multiple nodes and then launch all sorts of different types of attacks from the nodes and can host various different types of servers and that sort of thing to help you gain access to other target systems. Yeah, and then it's built in Ruby, which I obviously mentioned, and then you can actually find it at that repo over there. So you'll be able to see the Metasploit framework, lots of sort of documentation and stuff, and it gets updated quite on a regular basis. Last one here was 19 hours ago since I refreshed the page. And if I can just find, there's the module sort of section. So this is where you'll generally find, okay, the internet's not working for me at the moment, but it's the modules where you'll find that type of people will be putting stuff into there. Cool. Meterpreter. Okay, so Meterpreter is sort of standalone. It has its own repo and that sort of thing, but it's also built into Metasploit. What Meterpreter is going to do is Metasploit is going to allow us to send a payload to the target system once we've managed to get the exploit to run. And the payload that's going to be in there is going to be to allow us to fire up this meterpreter shell. What's really, really great with this meterpreter shell is it has a full client-side Ruby API. So you'll be able to do things like actually open up an IRB console once you actually are inside the target system. Yeah, and then it comes with a whole pile of other things, command history, tab completion channels, and lots of features into it. It's actually really, really powerful once you actually get in to be able to use the meterpreter shell. Cool, so going on to the exploits, a few different types of exploits just mentioned there. You've got like the buffer overflow exploit, remote code execution, and web delivery exploits. Specifically going to look at the remote code execution and web delivery stuff today. But before getting to that, just so you get an idea of what the exploits are, exploit is basically exploiting a vulnerability on a system, to put it bluntly. There's something wrong with the security aspect of your system, and somehow you're able to gain access to that system through the exploit. This basically is generally done. It's not as cool as what they do in Hollywood, where someone will find a computer and access it remotely immediately. Usually things are set up by using these sort of tools with metasploit when you actually are attacking the target machine. But before that happens, someone is going to sit down and they're going to set up that same environment that they wish to attack. They're going to isolate that vulnerability, and they're going to spend quite a lot of time doing all sorts of things against that target machine, being able to watch the logs in that machine and seeing what's actually happening there. Once they've done that, they're able to isolate where the problem comes in. So if you're doing like a buffer overflow, you're able to overflow the buffer, and you can actually watch the logs and see where things are appearing in the buffer so that you can overload the correct pointers, overload the correct registers. And once you know that information, you can then use that to attack the machine. So the exploit's basically giving us that opening. Something else which is important to know is the reverse shell versus the bind shell. The bind shell, basically the target machine would set it up and open up the ports and everything, and then you can gain access to it from the outside. The reverse shell is pretty cool because you're able to tell from outside of that, you can actually tell the target to connect out to your listening host. What makes this really great is usually you can't just connect into any target system. Generally firewalls, routers, and all that sort of thing will stop you from doing that. But those sort of things that are in place, at least the defaults, aren't going to stop a machine from connecting out to the internet. So if you can tell that machine to connect out to the internet, you can grab a connection from it because you're bypassing a lot of those default security things that are in there already. Okay, cool. So remote code execution, kind of what its name suggests, you're able to execute any command on the target system. So if you can get in and execute commands, you're able to do pretty much whatever you like. Also known as arbitrary code execution. And then there's the web delivery. Web delivery is something that would be quite common in if you're downloading dodgy attachments from emails and that sort of thing. You're going to have a host that's going to set up a server that's listening, and the web delivery will basically be a command that will run on the target machine, which is going to tell that target machine to connect out to get to your listening host, which will then return the payload, which is going to give you the shell into the target machine. What's really, really great about the web delivery is the fingerprint is very, very low. So you're going to find that a lot of sort of prevention systems aren't going to be able to pick it up because there's nothing actually being put onto the target machine. The target machine is just directly connecting out, and if that command can run, no antiviruses or anything like that are actually going to pick it up to stop you from getting this to run. Cool, so just quickly before we actually get to metasploit, some of the things that we can do with it is we can use it in conjunction with a lot of tools, specifically with scanners. So there's a whole range of different scanners that you can use. Some examples are things like Nmap, OpenVAS, Nessus, and so on. And a lot of these scanners actually tie into metasploit. You can do a whole scan of the network and import the database into metasploit, which you can then use directly from there. Nmap here is going to scan it. It's going to tell us what's open on the network, which ports are open, what services are using, and it starts to give us a bit more information about what can be used. We can even tell it to give us details about the operating system. You'll see at the bottom there, it's even telling us what service pack and that sort of thing is running. The more information you have about the system, the more likely you're going to be able to break into it because you'll be able to find vulnerabilities far more easily. The other one there, that OpenVAS at the bottom, that one specifically will actually point out vulnerabilities on the system to you. So you actually don't even have to go look for the vulnerabilities yourself. Yeah, basic steps that you're going to be doing is you're going to choose and configure the exploit. So the exploit is actually what's the vulnerability on the system. It's going to give you that access. And then point number 3 is configuring the payload. So that's where I mentioned there, it's quite modular. You're able to choose the exploit and choose the payload because they're quite specific to the system. Systems vary from here and there, so you actually need to be able to configure that correctly. That point number 2, where you can check whether the intended target system is susceptible to the chosen exploit. All this really is built into the exploit. You can run a method called check, and if that method exists, it will be able to maybe tell you whether the system is vulnerable or not to your chosen exploit. This often isn't around in exploits. The reason for that being is developers, when they're putting together the exploits, actually have to create the method themselves, which is just extra time and effort on their part. Also, you know, when you're actually running these penetration testing tools, you're doing it with permission, right? So if it didn't work and it raised a red flag, it really shouldn't be that big of a deal because, you know, we have permission to do that. Yeah, and then you can choose the encoding techniques to prevent intrusion detection systems, prevention systems. Basically what that means is you will often find, especially with malware and viruses and stuff, that's how antiviruses work, is they just basically generate a signature hash, and then the antiviruses compare the EXEs and stuff before they run to those signatures that get produced to tell you if it's malware or not. What you can do here to prevent those sort of systems from detecting it is you can add irrelevant bits of code to your code that's actually going to run. These are usually like null byte characters or something that's not going to break the system, but it's going to actually change the signature so that they can't be detected when they get pushed into the system. And yeah, then we just execute the exploit. So there's just a bit more details. You can figure out the operating system, what network services are running, all that sort of thing, what's vulnerable, and run your various different scanners. Cool, so what we're actually going to be doing here is we're going to find the exploit that we want, set it for use, set the required information, run the exploit, and then use the interpreter session. So yeah, our goal here for this initial part is to get access to a Rails server, and we're going to be using the dynamic render file upload remote execution exploit that's available. So quickly, just to look at that exploit. Is this big enough to see? Cool. So on the exploit, this is a really, really great website that you can go to, exploitdb.com. They list a whole range of different exploits that are available, and it gives you a whole pile of information about it. One of the things that is really, really useful to see is this ranking over here. Excellent ranking means odds are it's going to work most times. When I've been testing this out myself, I've had to run it twice sometimes, which doesn't fully make sense, but in general, I get the shell access. You'll also find a whole pile of information that the author of the exploit is going to tell you about. In this case, the specific problem that we're actually going to be exploiting is this method. Okay? So hypothetically, if you have that method in your code base, you're vulnerable to this exploit. So I don't know how many of you have ever seen that sort of method, but you know, I've seen it quite a few times. The only thing to note with this is a vulnerability on Rails systems running 4.0.8 or lower. So if you're running a Rails system older than 4.08, then you are theoretically vulnerable to this unless you are implementing some manual strategies to prevent it. The other thing that has to go alongside with this is you need any post endpoint. Doesn't matter which one, as long as the exploit can find it, any post endpoint is going to give us that. What's going to happen is it's going to upload a file to this post endpoint, a temp file, and then because of this dynamic render action, we're going to be able to execute that code. If you go through it, you can go through it in quite a lot of detail. You can find authors are usually listed on it somewhere as well. And yeah, so this one actually has the check method, so we can run the check method to see if it would work against the system or not. This one's been implemented. And then we have the things like the send payload methods and so on. This rand text alpha method that's actually running here, this kind of speaks to what I was mentioning about code that could break the system. So these variables that are being set, like the FN is for the file name that we're going to actually send up, but it's using this rand text alpha, which has been specifically set up to generate characters that won't break the system, but still be unique enough that we can work with it. So it sets all this thing up, it sets up the commands and stuff that's going to want to run inside of the file, and it sets up the details about posting it through to there with creating the temp files and so on. We start our own HTTP server on our side to listen for when that exploit runs. It's going to connect to our HTTP server so that we can actually send the payload across, and then rendering the temp file, we've got all the details for that. And then the actual exploit method that runs over there. Cool. So that's just a quick view of what the actual exploit looks like when we've got it in Ruby. A lot of that work will be done outside of Ruby, but then it gets built into the Ruby setup there, and that gets used on the actual metasploit framework there. Okay, so now we hope that the demo gods are with us today. So we'll quickly look at what I've got here. Okay, is that all visible? Cool. So looking here, I've just set up a basic Rails app running 4.0.8. The show action that's required, and just any random post endpoint that I've got set up there. And then I have the server running on the side. So going back to my, and go to my Kali Linux box. Okay, cool. So then we have a shell on Kali Linux here, and we are able to, we might need to know what our IP address is. We can just double check our IP there. And then we can fire up the Metasploit Framework console. Okay, so once we have this console up, we're actually able to find our exploits that we're going to be running. So we will be able to, assuming we have view into, sorry, the screen is apparently smaller than expected. Okay, cool. So we'll be able to use over here, but before we actually use, we want to find what we're going to be doing. So we're going to do a search for the Rails gem. I had a few issues yesterday, so I had to reinstall Kali, which is why this stuff is not cached yet, but we should expect that to return the exploit we're looking for at the moment. So we're actually able to search for a whole pile of exploits inside of Metasploit, and then when that comes back to us, we're able to see what sort of options come back. So I'll just grab this one here. Cool. And then we can tell it to use it. So there, it loads it for use, and we can get a whole pile of information from it. We can type in info, and it will spit out a lot of information for it. So we can see what it runs on, what it's going to give us, the rank that it has, when it was disclosed. So this was actually from October last year. Authors of it, etc. And then we can see sort of options that we're going to need to be able to set for this specific exploit. So the options that we're going to need to set here, my endpoint is not users, it's dynamic files, so I'll need to update that. Going to need to set the rhost. Rhost is the target address, so we'll need to set the address of the listening system. And we will need to set just the fact that it's running on a virtual machine at the bottom there. Before I get to that, I just want to go to this here. Okay, so I have the server running on my very good looking web page. And cool, so we're going to start setting those sort of values. So we will set the target host, which is running on this address over here. And we are going to also set our URI path. And we're going to set the vhost to true. So again, we can look at the information here, and we can see what we've done has actually been updated. We've got our host set, our port is already set there for us, and then we've updated the vhost there. So all that really needs to happen now. Just going to quickly jump back to this so we can see the server log. Cool, and then we can just run the exploit. And okay, so what you see here is happening. So it connects to the service, it uploads the image, injects the payload, transmits it, sends the stage of the payload, and it actually creates this interpreter session for us here, and then deletes that temporary file that we had. Before we actually make use of that, just going to quickly look at the server, and so we can actually see what happened. Okay, cool. So here you can actually see the post that came through. So it posted to our random endpoint that we had, and it started processing the file, and we can see here how it created the temp file for us. What's very interesting to see is we actually get an invalid authenticity token. However, the exploit doesn't really care about that, and it moves on to the next part, where we then get to our get action. So it hits our show action, the dynamic render, and it finds the temp file that we've uploaded, and it eventually gets down to connecting to our server that we're running on, connects to that, and it downloads the payload that we have for it, which then sends the payload and executes the payload for our side. So now that we have the payload, we're actually able to have a look at our sessions. We have one session active over there, so we can connect to that session. So once we connect to the session, we get our Meterpreter shell. Okay? Inside this Meterpreter shell, we can do all sorts of things. So can ls onto that, we can see the entire Rails server. However, we're not just necessarily restricted to that. We could do all sorts of things like this. And we could have a look at the entire computer system. So we can go around the entire computer system. But we'll go back into my copy paste here doesn't want to work properly, so I'll just, my tab and stuff isn't working. Cool, so we'll just feed into that. Okay, so we're back in here. So what else could we possibly do with this? Well, maybe we know a few things about their Rails stuff. So we can go look for their view files. And we see a view file there, which is pretty cool. So what else can we do with it? Well, maybe we want to do a bit of editing on that. Cool. This is where we're going to struggle with scrolling. Cool. And look, we have access to the edit file. Normal Vim terminal. If you know Vim, you'll be good to go in here. So maybe we want to do things like and then we'll move on our merry way. Cool. So let's fix the scrolling quickly. We can do all sorts of things. Meterpreter comes with a heck of a lot of different operations you can have. You can download and so on. We can fire up our own IRB terminal if we want, run Ruby scripts, run Ruby code, all sorts of things there. Lots of information to work with on that. And yeah, so you can download the files. The one other thing I wanted to look at here is check where we are. Cool. So we can then go into the config file. Sorry. Okay, so once we're in config, maybe we see they have a secrets file. Cool. So we can get all sorts of different information from the server. Yes. You actually can. I don't have any environment variables set here, but you can actually get to the environment variables if you do want to. That is an option that Meterpreter gives you, especially because we can get the full IRB console and all that sort of stuff. We have access to all that type of thing. This doesn't give us direct access to the database, though. You might have to find another way into that. Cool. So once we're done with that, we can come back on this side. I think the server has maybe got slightly stuck, so we'll just remind it where it's at. But then we can come back to our web page here, and the person will reload the web page, and unfortunately, maybe there was a bit of an intrusion. Cool. And then just quickly looking on to the next one, web delivery exploits into a Windows system. So the web delivery is the different one. This is one where we're going to set up a listening host or listening server on the host, and the target will connect to that. So, wrong virtual machine. Cool. So we're actually going to look for the web delivery exploit now instead. And oh, sorry, we need to search for it. Cool. So we'll search for that web delivery. Again, reinstalling Kali Linux means your searches are a bit slower. Cool. Oh well, I'll just start the. Okay, so there's actually a web delivery there, though. We can grab that web delivery script, and again, we can find out information about that web delivery. So here we can go through, we can look and see what we have. The rank here is actually manual, which just makes it a bit more interesting. This is the one where you would do things like actually drop this command into a hidden file, into something that the user is going to accidentally run, send it to the HR department in the disguise of being a CV in a PDF or something, and you're likely to gain access to their system. The platforms that this will run off of is Python, PHP, and Windows. Running it against like a Linux system, you need to have one of these sort of things installed. Thankfully, Python comes pre-installed, PHP doesn't necessarily, and Windows just uses PowerShell. So you always have access on the PowerShell front. Yeah, I was showing this to someone else the other day, and I discovered that this author here actually works in our MWR offices in the UK. So we have quite a lot of people who contribute to these sort of things. It's a very, very active community. Cool. What we're going to do here is we can show our options. And these are the things that we need to look at setting. So we don't actually want to run Python, so we're actually going to set our targets to 2 so that we can change that to be using PowerShell. And we just need to set our listening host to the what this server is here. So we're running on 106, so we can just set our listening host to that. And then we also need to set a payload. So how we're going to choose the payload that we want. So we're going to set our payload. It's going to be running on a Windows machine. Unfortunately, I hit tab, which I should not have done. And we're going to be using a reverse TCP for this as well. Okay, so again, we can show the options. We can see what we've set. So we can see here, oh, there we go. We've set our RP. It's going to be listening on that port, and we're going to be using PowerShell. So once we have all of that set up, we can fire up our server. Cool. So what this is going to do is this gives us a okay, so this gives us a PowerShell command that's going to need to be run on the system. I'm just going to drop this, although we'll see how well it works. I've been having issues with copy-paste. But I can drop this into the Windows box, and it should run it for us. Let's just see if we can actually copy-paste across. No, that's the wrong one. Okay, cool. So I'll quickly sort that out. Okay. All right, so just what you'll see here is we have this unique identifier over there, which you're going to be using. And just to make sure I can, all right, cool. Just want to make sure I can see it properly. Okay, so this unique identifier is actually what we're looking for running that, although it's the wrong one. Okay, cool. Okay, I can see that now. And we have ZZ5Q. Okay. Cool. So now we can just grab this PowerShell command. And did I grab the wrong one? Damn. Cool. Drop that in here. And then that runs and actually closes that down for us. It takes a bit of time for it to connect back to the server, assuming you don't have any mistyped identifiers on that, and we should actually see it come through on the side when it connects to it. There we go. So it connects to the server, sends the payload across, and we can see over here that the interpreter session has been opened. So we're actually able to just grab that session, and we can connect into the box from there. Again, we have full access to the system, and we can actually see all the different files, everything else that the user has in that. Scrolling down. Cool. And we can do all sorts of things. We can navigate around the system. Again, fire up IRB terminals and so on. Something that I really wanted to do. Unfortunately, this worked yesterday and didn't want to work today. So the webcam is not working for me in my favor. The other thing to know with the webcam is it actually works only really against Windows machines. If you're running Unix, this doesn't work on a Unix system, but it's not very happy with my webcam running in a virtual machine. I brought an extra machine with me, but apparently that webcam doesn't work. Cool, but what we can do here instead is we can do other sorts of commands that come along with us, and we can run things like that. And we can then just go here quickly, and we can have a look and see what the user is maybe looking at themselves. So we can do all sorts of things like that. The webcam, if you want to be super creepy, comes with all sorts of things like streaming. You can record microphones and all that sort of stuff if you actually get into these systems. So that gives you a whole pile of stuff there. And then once you're done, exit out of it, and your trace is lost from the target machine. Cool. And whoops, wrong one. Awesome. Thanks, guys. And any questions? Yeah. So the biggest thing for this is really patching your systems, especially if you're talking about like a server running websites and stuff. From that point of view, if you generally stuff is kept up to date, follow the right streams, make sure you're aware of vulnerabilities that get announced, and then patch your systems, you will protect against a large part of this. Also, the user not being aware, like I say, a large problem is people may be downloading a CV that they're looking at. They're not fully aware that maybe it has some random extension on the end, or they enable macros. Very, very common thing, downloading a Word document. How many of you download a Word document and ask you to enable macros? Yeah, don't click yes. It's a bad idea. So all those sort of things are actually what gains access to the system. You'll find things like firewalls and stuff, especially with this web delivery, won't stop it unless you've gone through the extreme measures of limiting what you're allowed to connect out to, what ports are allowed to open up. And that is a manual setting that generally you're not going to do on a firewall. If you're very pedantic, you can go set up firewalls with those sort of rules to prevent you connecting out with certain ports and so on. That will help. But yeah, in general, the user just needs to be aware and keep up to date. Cool. Anyone? Yes?
I assume something like Brakeman for Rails projects will help you sort of not get into the position.
Oh yes, very much so. Brakeman will pick up all these sort of vulnerabilities on Rails. This was a new vulnerability, but I'm pretty sure Brakeman actually like picks it up and all that sort of thing. Yeah, so running those sort of tools is definitely going to help you. Cool. Good. Great. Thanks, guys.